In this video, we'll be looking at how we can prove that lines are parallel, and we're going to be using the converses of the theorems that we've talked about so far for parallel lines and their transversals. So a reminder that when we first started learning about conditional statements or if-then statements, we had them in the form if P then Q, and the converse was the reverse of that statement, if Q then P. So for an example, our corresponding angles theorem said that if two lines are parallel and they're cut by a transversal, then the corresponding angles will be congruent. So the converse of that will be that if you have two lines that are cut by a transversal and they have congruent corresponding angles, then that makes the two lines parallel. So what we're doing is essentially reversing the order of each of our theorems that we talked about. So if alternate interior angles are congruent, then their two lines are parallel. When alternate exterior angles are congruent, then those two lines are parallel. And then remember that our consecutive interior angles have that supplementary relationship. So if those are supplementary, then that makes the lines parallel. So we're kind of just going in the reverse here. So now we're looking for angle pairs to be congruent or supplementary to then claim that lines are parallel. So in this first set of examples, it says that lines A and B intersect lines C and D. So while they may appear parallel, we're not sure based on the diagram and the given information. So it says to write a congruent statement that would prove line C is parallel to line D. So if I'm focusing on line C being parallel to line D, I'm going to focus on their two transversals. So if I consider the transversal A, then I can see that I've got an angle pair right here of 1 and 4. And if 1 and 4 were congruent, then that would make our lines C and D parallel by the converse of the corresponding angles theorem, because those are two corresponding angles that are now congruent. Another way that we could have done that would be to say that 1 and 6 are congruent. And if we knew that 1 was congruent to 6, then by the converse of our alternate exterior angles theorem, those could be congruent. Or one other way we could have done it would be to say that if 2 and 4 were supplementary, then I would know that by the converse of the consecutive interior angles theorem that I would have line C parallel to line D. Another way I could have done it was to not even look at the transversal A, but instead look at transversal B. And I could have also stated that angle 3 and angle 5 are congruent, and using the converse of corresponding angles theorem, I would state that the two lines C and D are parallel. So a lot of options there in order to claim that they were parallel to one another. In the second example, it says to write a congruent statement that would prove line A is parallel to line B. So this time I want to try to find what transversal relationship angle pairs I can find. So if I focus on the transversal of C, I can see that 3 and 2 would be alternate exterior angles. So if I had a statement that said angle 3 is congruent to angle 2, then by the converse of the alternate exterior angles theorem, then I would be able to say that since they're congruent, A and B would be parallel lines. If I focus on the transversal of D, there are no angle pairs that I can see here with any of our theorems to claim. So the option B is our only one option of 3 and 2 being congruent, versus in option A we had a lot of different scenarios that we could have used. So down below we're going to look at this new diagram where we have line A, B, and L and M. And we're going to be given a congruent statement and then see if we can determine whether that makes the lines parallel or not. If they are parallel, then we're going to state which theorem makes them parallel. So in the first example, I've got angle 3 and angle 11. So focusing on 3 and 11, I can see that they are both touching the line B, and then B is a transversal for L and M. So because those two angles are corresponding to one another, then by the converse of the corresponding angles theorem, I could state that those two lines L and M are parallel. So L would be parallel to M. In the next example, we're given that angle 7 is congruent to angle 9. So looking in the diagram, 7 and 9 are both touching the same transversal A. So I can see that they are sharing that transversal, but they're on different sides of the line. And A is intersecting both lines L and M. So if those two angles are going to be congruent, then using the converse of the alternate interior angles theorem would let me state that those two lines L and M are parallel. Next example is angle 1 and angle 5. So finding angle 1 first, we've got angle 1 right here and angle 5 out here. So 1 and 5 are both touching the same transversal line L, which is a transversal for lines A and B. So what that tells me is that since 1 and 5 are congruent, then by the converse of the alternate exterior angles theorem, that line A would be parallel to line B. And then the final example, we're told that angle 1 is congruent to angle 13. So notice that those two angles are not touching the same transversal because 13 is touching B while 1 is touching A. Or if you wanted to look at it as 13 is touching M and 1 is touching L. Lots of letters, sorry. Regardless, we are not able to state anything is parallel here because these two angles unfortunately do not have a direct relationship. So if we were given that information, with what we know right now, we would not have enough information to prove that those two lines are parallel. So now we're going to use what we just talked about with our converses and apply them to our two-column proofs. So similar to when we first started with our proofs, we're still able to use our definitions, our theorems, and all of the properties that we've talked about. But now that we've learned a few new converses of theorems, we can also apply those as reasons. So we're going to look at these diagrams, look at the given information, and try to fill in what we have given to us. So in the first proof, it says given angle 7 is supplementary to angle 2. So looking at them on the diagram, if I were to just look at this, I don't have enough information necessarily to assume that that is true, but because it is given, we can believe that, right? It's part of our proof. We're being asked with that information to prove that line L will be parallel to line N in the diagram. So we're trying to prove that these are congruent, meaning we don't know they are, or sorry, not congruent. We're trying to prove that they are parallel. So we don't know for sure that they're parallel. So we can't just prove that 7 and 2 should be supplementary based on some theorem, right? We need to kind of jump through some hoops here to figure out why they are going to be supplementary, okay? So let's figure out kind of what we're working with. If I start with my first statement, it says it was given, so I'm just going to repeat what was above. So 7, the angle is supplementary to the angle 2. And then in the next line, it's already written out that measure of angle 7 plus measure of angle 2 equals 180. So in order to go from line 1 to line 2, I'm applying the definition of supplementary angles, right? Because that definition tells me that those two angles should add up to 180 degrees. Looking at the next line, it says that the measure of angle 7 plus the measure of angle 6 equals 180. So if I look for 7 and 6 in the diagram, I can actually see that those are a linear pair. So I'm going to use the definition of linear pair here because I can see that they are a linear pair given the diagram. So another way that you could state that as a reason is that it was given in the diagram, that they're on the same line, but you would want to make sure that you're recognizing that they are a linear pair, and that is why we're setting them equal to 180 as their sum. So then looking at the next line, I see that I've made kind of a big jump here. I'm going from measure of angle 7 plus measure of angle 2, and I'm setting it equal to the measure of angle 7 plus the measure of angle 6, right? And the thing that's connecting them above is that 180 degrees. So what we're really using right here is an example of our transitive property. We're saying that because both of those expressions were equal to the same value, then they must be equal to each other. Looking down at the next line, we're missing a statement, but the reason is the subtraction property of equality, meaning we're taking something away from both sides to remain equal. So I can see that both sides of this last equation had the measure of angle 7. So if I were to subtract the measure of angle 7 from both sides, then I would be left with just the measure of angle 2 equals the measure of angle 6. And that would be based on our subtraction property of equality. Very subtle change on the next line then. We're going from measure of angle 2 being equal to measure of angle 6 to now knowing that the angle 2 is congruent to the angle 6. And remember that when we switch between our equal sign for numbers and our congruent sign for segments or angles, that's just relying on our definition of congruence. So then applying that to our diagram, angle 2 and angle 6, because I've now made that statement without using their angle pair specifically, I've proven that they're congruent. Well, now I can see that if I'm talking about these two lines and wanting them to be parallel, 2 and 6 are an example of corresponding angles. So the converse of the corresponding angles theorem is what's going to support me in saying that the lines L and N are going to be parallel, because I'm now stating that I have two corresponding angles which are congruent, therefore the two lines that they are with must be parallel. In our second proof, we are given that the angle 8 is congruent to the angle 2. We are trying again to prove that L is parallel to N here. So not using the known properties to prove it, we're trying to work through what is given to us. So if I look at the diagram, right, see how I have 8 and 2. Now, a lot of us are going to automatically say, well, that has to be equal because they're alternate exterior angles, right? What we're really trying to show is why those two lines are parallel, and using that alternate exterior angle relationship is not going to be like what we're trying to look for. We're really trying to prove why that is actually true. So we're going to take a look at the steps that have been written out for us. We have angle 8 congruent to angle 2, which is given, right? So even though they look like alternate exterior angles, and they are, right, we are not using that as the reason, okay? Now we're looking at angle 2 being congruent to a different angle that we need to fill in based on the definition of vertical angles. So if I look back at my diagram, I can see that 2 and 4 are actually vertical angles, right? So I would be able to make the claim that angle 2 is congruent to angle 4 based on their definition. Then, moving forward from there, I see that I'm citing the transitive property. I've used angle 2 twice now, and it's connecting angle 8 with angle 4. So I can make the jump to connect 8 and 4 together somehow using the transitive property. And then let's look at our diagram of why that might help us, right? Angle 8 and angle 4 are corresponding angles. I've just proved that they are congruent. So based on the converse of the corresponding angles theorem, I can now state that those two lines, L and N, are parallel. So we couldn't just use the converse of alternate exterior angles from the beginning because we wanted to show why that is actually true, right? So you're essentially proving how that converse works. Our final proof here starts with angle 7 being supplementary to angle 4. So that is just our given information, and looking at them in the diagram, we wouldn't really be able to see anything special about those two. There's not really a relationship there, okay? But we're going to try to prove that the line L is parallel to the line N. So if I look down at the next line, it's using the definition of supplementary, and above I was connecting 4 and 7 as being supplementary, so I can state that the measure of angle 7 plus the measure of angle 4 will equal 180 degrees. Then looking at my picture up here, I can see that I have angle 7 is congruent to something based on the vertical angles theorem or definition. So 7 is a vertical angle with 5. So I'm going to go ahead and state that those are congruent based on the definition of vertical angles. And then switching from congruence to equals, right? We're using our definition of congruence here to make that jump. And then I can see that we're being asked to use the substitution property. So looking back at what we've done and what we're trying to prove, think about what we could sub in here. We've shown that 7 and 4 are supplementary, and we've also shown that 7 and 5 are equal. So where I see 7, I could replace with 5. So I'm going to rewrite that line 2, but in place of 7, I'm going to say the measure of angle 5, and then I'm going to say plus the measure of angle 4 equals 180, and that's our substitution property of equality. So therefore, what I can tell is that those two angles are supplementary, and so really I should include one more line here. I should state that angle 5 and angle 4 are supplementary, okay, and that's going to be based on the definition of supplementary angles. And then I can make my final line that L is parallel to N here. Those two lines can now be stated as parallel because 4 and 5 were the same side interior or consecutive interior angles. So when we have those being supplementary, I can use the converse of the consecutive interior angles theorem in order to prove why those two lines are parallel. So make sure you go ahead and add in that extra line there because I did try to make a jump that I wasn't ready to do. So I just can ignore that. We're going to fill in that line. 4 and 5 were supplementary because of the definition of what supplementary angles are. And then we can show that because they were supplementary, that converse gets us the parallel lines.